So section 3.4, the zeros of polynomial functions. The first thing is the fundamental theorem of algebra. That's what they're going to ask you with the first questions. If f of x is a polynomial of degree n, and n is a positive number, then f has at least one zero in a complex number system. So at least we have 1 0 for this polynomial function. That's what they're going to ask you with the first questions. So if I have polynomial function with degree n and n is a positive number, then f has at least 1 0 in complex number system. We're going to use this one, linear factorization theorem. If f of x is a polynomial of degree n and n is positive, because if n is a negative number, it's not a polynomial. So always n is a positive number. Then f has precisely n linear factors. That means when you factor the polynomial, you're going to get n linear factors. For example, f of x is an, x minus c1, the first factor, x minus c2, the second factor, and keep going. Where c1, c2, and cn are complex number. We're going to check that when we solve an example. This is the important thing, which is rational zero test. So now, before we go into the rational zero test, any polynomial with degree n has n linear factors. So if it's degree 3, that means we have 3 linear factors. If it's degree 5, that means we have n 5 linear factors. If you check the first example and what they ask you, not the first one, this example 5. If you check example 5, they're telling you here with this theorem, if the degree of polynomial n, that means we have n linear factors, n linear factors, or n zeros. You can say we have n zeros, n zeros, which is the same thing. So if you look to this example 5, determine the number of zeros. They're telling you how many numbers of zeros do you have here. The degree of the polynomial is a 3. That means we have 3 zeros or 3 factors. Because remember, I told you zeros is the same thing, the factors, it's the same thing, the solutions. So the degree for this polynomial is a 3. That means we have 3 zeros. The same thing with this one, but be careful. You have to look to the highest exponent. You have to look to the highest exponent. So if you look to the next example, the highest exponent is n equal 5. That means the degree for this polynomial is 5. So that means we have 5 zeros on this one. We have 5 zeros because they said if the degree n, that means you have n linear factors or n zeros. That means n solutions. So this is this example. We're going to keep going. We're going to keep working on these examples, but first, let's check the rational zero test. If is the test, what's the meaning of this test? This is a really important test. Before you start factoring the polynomial, you have to find all possible zeros. That's what we're going to use. Is a test that gives a list of rational zeros of the polynomial function. So before I start factoring the polynomial, I'm going to find all possible zeros by using this test. All possible zeros, I'm going to depend about polynomial. So I'm going to say P equal the constant, the factors of, let's write down the factors of A naught, which is the constant. And Q is the factors of an. The all possible zeros is going to be p over q. Let's write down here, p over q. These are all possible zeros, and when we do examples, it's going to be easier for you to find these possible zeros. But keep in your mind, p is the factors of a naught, and q is the factors of an. Note here, if this is a complex number, this one is the conjugate, and the opposite thing is going to be right. If this is the complex number, this one is going to be the conjugate. Let's keep working on example 7. Example 7, determine the numbers of zeros. Here is the highest exponent. That means we have 6 zeros. If we check the next example, now we have x plus 5 squared. So be careful from this example. How many zeros with this one? First of all, we have to simplify f of x. So f of x is the same thing as x plus 5 and x plus 5. So now we have to simplify this one. That means FOIL it. X times x. That means f of x is going to be x squared. X times 5. So it's going to be 5x. Now 5 times x is going to be 5x. And 5 times 5 is going to be 25. That means f of x equal x squared plus 10x plus 25. Now in this case, n equal 2, which is the highest exponent. You're right, you can say that from here, it's x squared. But now n equal 2, that means we have 2 zeros. That's it for this example. But if you look to example 9, so 2 zeros here. With example 9, you're going to say, okay, the highest exponent is 2. That means I have 2 zeros. No, don't do that. First of all, do the same steps, simplify. So we have h of t equal t minus 9 squared minus t plus 9 squared. So what I'm going to do, I'm going to simplify this one. So this is h of t equal. This parenthesis squared, that means it's t minus 9 times t minus 9. And here's minus. I'm going to open bracket because I'm going to separate these two parentheses on this one, which is t plus 9, and another parenthesis t plus 9. I'm going to FOIL this one. I'm going to FOIL this one. So h of t is going to be equal. T times t is going to be t squared. T times negative 9 is going to be negative 9t. Negative 9 times t, negative 9t. And negative 9 times negative 9 is going to be plus 81. Here's the minus. Let's do the same thing here. T times t is going to be t squared. T times 9 is going to be plus 9t. 9 times t is going to be plus 9t. And 9 times 9 is going to be plus 81. So now the next step, I have to FOIL the negative sign, distribute the negative sign here. First of all, combine the like terms. T squared minus 18t, because these are the same like term. And then plus 81 minus, I'm going to do the same thing here, combine the like terms. T squared plus 18t plus 81. Then next step, I'm going to distribute the negative sign. So h of t is going to be t squared minus 18t plus 81. Negative times positive is going to be minus t squared. Negative times positive is going to be minus 18t. Negative times positive is going to be minus 81. Now, in this case, combining the like terms, t squared minus t squared is going to cancel. It means 0. AU1 minus AU1 is going to be 0. Now, negative 18, you're just going to add 18 with the 18. So negative 18 minus 18 is going to be 36. That means here it's going to be negative 36t. If you look here, after you simplify everything, it's squared and simplified became t. That means now n equal 1. So we have only 1, 0. So it's important to simplify before you start putting how many zeros do you have. So here we have only 1, 0. So let's find all possible zeros here. They're telling you use the rational zero test to list all the possible rational zeros of f. Verify that zeros with the graph. You're going to verify these zeros with the graph. We're going to list all possible zeros. And then by looking to the graph, we already know this is going to be 0 because it's the x-intercept, which is this point and this point, the x-intercept here, and the x-intercept here, and the x-intercept here. But now we have a graph. We can verify the zeros because I already know the zeros, it's mean the x-intercept. So here's the x-intercept, here's the x-intercept, and here's the x-intercept. So I already know x equal negative 3 and x equal negative 1. This is the second zero, and x equal 1. So I already know from the graph, these are the zeros of the x-intercept. But now I need to find all the list of these possible zeros. Because next example, we're not going to get a graph. We have to factor the polynomial. So first of all, on example 10, the polynomial function, it says f of x equal x cubed and plus 3x squared minus x minus 3. I need to find all possible zeros, not the actual zeros, just the possible zeros. So what I'm going to do, always P is the factor of A naught. P is the factor of A naught. And the Q is the factor of AN. So that's fine. A naught equal, A naught, which is the constant, 3. I'm just going to take the number because I'm going to find all factors for this one. And AN is the highest, the leading coefficient for the polynomial, which is 1. Now, P equal what? All the factors for the 3. That means which number you're going to multiply by other number to get 3 or negative 3. We can multiply 1 times 3 or negative 1 times negative 3. So plus or minus 1. The second one, plus or minus 3. Because why I'm doing that? Because if you multiply 1 times 3 is going to be 3. negative 1 times negative 3 is going to be 3. So these are the possibles. Positive negative 1 and positive negative 3. These are the P. All the factors for A naught. Q is going to be all factors for AN. Q is all factors for AN. So the factors for 1 is just plus or minus 1. Now we need to find all possible zeros, which is P divided by Q. So I'm going to start. Plus or minus 1 divided by plus or minus 1 is going to be the same thing, plus or minus 1. Like I'm dividing this one by this one. You can write down here and the result. It's a plus or minus 1 divided plus or minus 1. The result, I'm going to write it down here. 1 divided by 1, positive divided by positive is going to be positive. Positive divided by negative is going to be negative. So the result is going to be plus or minus 1. Now the second one, P divided by Q, because we have 2P here. So that means plus or minus 3 divided by plus or minus 1. So it's going to be plus or minus 3. Now, if you look here, that means how many possible zeros do we have? Because here, all the possible zeros, the possible zeros is, we have 1, -1, 3, and -3. We have 3 or 4 possible zeros. These are,
you move the, I'm sorry, could you move the page up a little bit? Thank you.
yes. So we have 4 possible zeros. We have 4 possible zeros. That means I'm going to type here, these are not the actual zeros. They ask you just to find the possible zeros. Okay, possible zeros, we have 1, -1, 3, -3. But one of these, 3 of these numbers are the actual possible zeros. We're going to learn that next example, how we're going to use the scientific division to find the actual zeros. So these are just the possible zeros. Let's check that. And if you look to the graph, the x-intercepts or the actual zeros from the graph, the actual zeros here, here, and here is one of these zeros, because 1 is the actual 0, and -1 is actual 0, and -3 is actual zeros. So that means before I start factoring the polynomial or find the actual zeros for the polynomial, first of all, I have to find all list of possible zeros. Then I'm going to show you what to do to find the actual zeros. But now they're just asking you, here's the possible zeros, and compare this one with the graph. You see, this is actual 0, this is the actual 0, this is actual 0, it exists here. That's mean that's it. So example 11, find all possible zeros. The function is f of x equal x cubed minus 25x squared minus 25x plus 6, 25. We have the graph. Let's find the possible zeros. So a naught equal 625 and an equal 1. So that means p equal all the factors for 625. It's okay, you can find it with using the calculator. So the first thing, always number 1 plus or minus 1, because plus or minus 1 times 625. So I'm going to write down 625 here, because 1 times 625 is going to be 625. So that's mean 1 and 625 is the factor of the polynomial. Next one, I can say 625, if you divide it by 5, is going to be 125. So I'm going to put a plus or minus 5, and here, plus or minus 125. Because 5 times 125 is 625. One more thing, if you multiply 25 times the 25, is going to be 625. That's mean we're going to put a plus or minus 25. So these are all the factors for A naught. Q is the factors for AN, which is only plus or minus 1. That means all possible zeros, P over Q is going to be. Going to start from the first one. This one divided by this one is going to be plus or minus 1. 5 divided by 1 is going to be plus or minus 5. And keep going. 25 divided by 1 is going to be plus or minus 25. 125 divided by 1 is going to be plus or minus 125. And 625 divided by 1 is going to be plus or minus 625. Now you see, these are all the possible zeros for this polynomial function. Let's type these possible zeros here. That's mean there's a way to write down a plus or minus. I think you can't. So let's check the operation. No, you can't. So I have to write down 1 and -1, comma, 5 and -5, comma, and you have to write down 25, comma, -25. That's mean you're gonna write down the positive and the negative. And 125, comma, -125. And the last possible zeros is 625, 625, comma, -625. Let's check these. And then if you look to the actual graph here, you're gonna find the actual zeros for the polynomial exist in one of these possible zeros. So here's, let's check the actual zeros. So this point here, you can't tell because it goes by 10. So this is 5, this is 10, that's mean on this one is the next one, on this one is the next one. How do you count this one? This is 20, this is supposed to be 5. And here is -5. If this is 5, this is -5. And here is the 25, because this one is 20 goes 2, 4, 6, 8, 10. Yeah, so this is the 25, and here is 2, 4, 6, 8, 10. So this is 5, and this is 2, 4, 6, 8, 10. That means this is -5. So the actual zeros, it's 5, -5, and positive 25. The positive 25, not the -1. So let's find the all possible zeros for this example. I'm not going to look to the graph. I'm going to say A naught, which is the constant, equal 45. And AN equal 2. So let's find P. P is the factors of A naught, which is plus or minus 1. And plus or minus 45, because 1 times 45 is going to be 45. Then which else we have start like this. So I'm going to show you because sometimes you have hard time to find the factors. So I'm going to say 45. You can divide by 2. By 3 is going to be 15. That's mean I'm going to say plus or minus 3. And here plus or minus 15. That's mean 3 times 15 is going to be 45. Next, we can say 45, if you divide by 9, is going to be 5. That means we have 5 and 9. So I'm going to say plus or minus 5 and the plus or minus 9. These are only the factors for P. Now we need to find the factors for Q, which is only have 2. So plus or minus 1 and the plus or minus 2. These are the factors for P and Q. To find P over Q, which is all possible zeros, is going to be this one divided by this one is going to be plus or minus 1. Then 3 divided by 1 is going to be plus or minus 3. And keep going. Because all these we're going to divide by 1. So plus or minus 5 divided by 1 is going to be 5. Plus or minus 9 divided by 1 is going to be plus or minus 9. 15 divided by 1 is going to be plus or minus 15. And 45 divided by 1 is going to be plus or minus 45. We have to keep going. Now we're going to divide all these numbers by 2. So the first one, 1 divided by 2 is going to be plus or minus 1 over 2. You can simplify it, just keep it. 3 divided by 2 is going to be plus or minus 3 over 2. 9 divided by 2, so it's going to be plus or minus 9 over 2. 15 divided by 2, so it's going to be plus or minus 15 over 2. 45 divided by 2, so it's going to be plus or minus 45 divided by 2. So all these are possible zeros. And you can see the actual zeros for this polynomial exist in one of these. So let's check the first one here. I'm not going to type it because we need a really long time. We're going to type everything here. So if you look to the actual zeros here, this is -1. -1, because negative 1 here is -2. -1 is exist on one of these zeros here. The second one here, this is negative, this is 1, and this is 2. So here's 1, that's mean 1.5. 1.5, which is a 3 over 2. 3 over 2 is 1.5. That means the positive 1 exists here, which is an actual 0. And the last one, I think this is 4. This is, because this is the 3. 3 also a 0, which is exists here. And here's 4. And this is 5. So 5 also is a 0. That means 1, -1, +3, +5, and +1.5, which is 3 over 2. These are the actual zeros. But now we just check in the actual zeros from the graph with the possible zeros. Next example, we're going to learn how to find that, how to find the actual zeros from the possible zeros. In this example, they ask you to find the rational zeros, not the possible zeros, but always the first step, you have to find the possible zeros. So this is always the first step. The first step, you're going to say A0 equal 30 and AN equal 1, with the leading coefficient 1 and the constant is 30. Now P is going to be equal the factors of A0, which is the 30. So it's plus or minus 1 and the plus or minus 30. Let's check what else. 2 times 15. So I'm going to say plus or minus 2 and plus or minus 15. What else? We have 5 and 6. So I'm going to say plus or minus 5 and the plus or minus 6. You see now all these is the factors of P. The factors of Q is we have just 1, so we can say plus or minus 1. To find all possible zeros, is going to be, we're going to divide everything with P over Q. So it's going to be plus or minus 1. 2 divided by 1 is going to be plus or minus 2. 5 divided by 1 is going to be plus or minus 5. 6 divided by 1 is going to be plus or minus 6. 15 divided by 1 is going to be plus or minus 15. And 30 divided by 1 is going to be plus or minus 30. So these are the possible zeros. That means we have +1, -1, +2, -2, +5, -5, and keep going. So next step, we need to find the actual zeros. So I'm going to start picking the first one. I'm going to say k equal 1. The first number here. K equal 1, that means the zeros is going to be x minus k, which is x minus 1. This is the first, if I said this is the first right zero, x minus 1. But I need to check, this is the right zero. What I'm going to do, I'm going to use the synthetic division. Don't forget there is a missing term here, which is the 0. So this one is x cubed plus 0x squared minus 31x minus 30. When I use the synthetic division, k equal 1, I'm going to write down the coefficient here. So 1, 0, negative 31, and 30, negative 30. You see, I'm just using the synthetic division. I'm going to start with k equal 1. I left the -1, and let's check. Just use the synthetic division, write down the first number, and then I'm going to multiply. 1 times 1 is going to be 1. Add these together, so it's going to be 1. 1 times 1 is going to be 1. Add these together is going to be negative 30. 1 times negative 30 is going to be negative 30. That means if you add these together, it's going to be negative 60. Check how much I got the result. If the remainder is not 0, r of x not equal to the 0, in this case, if the remainder is not 0, that means this is not an actual 0. If the remainder is not 0, that means k is not an actual 0 for this polynomial function. So I'm just going to cancel it. I'm going to go to the -1. I'm going to say the second option I have k equal -1. I'm going to do the same steps. I'm telling you, you're not going to use all these zeros. So -1. Then I'm going to do the same steps. Write down 1, 0, negative 31, and negative 30. Now let's do the synthetic division here. Now I'm not going to look here. This is done because the remainder is not 0. I'm not going to look to this part. I'm going to do the same operation again, but I'm going to pick the -1. Now here is 1. -1 times 1 is going to be -1. Add these together, 0 plus -1 is going to be -1. -1 times -1 is going to be 1. Add these together is going to be negative 30. Now, -1 times negative 30 is going to be 30. Add these together is going to be 0. Now, my remainder is equal 0. That means this one, which is x minus k, is going to be x, move the -1 plus 1. So this is an actual 0. The first 0 is x plus 1. You see, because k equal -1, I'm going to move -1 to the other side. So it's going to be x minus k. So x minus -1, which is x equal 1. Or you can do that because here is our factors. So you're not going to get confused here how I'm going to find it. I'm going to say x minus how much the k? The k is -1. That means it's going to be x plus 1. So this is the first factor. Now let's check here. With the scientific division, this is the constant. This is x squared. Let's write down this. That means my function here, f of x is going to be equal x plus 1 and x squared minus x minus 30. If you look to this one, it's a quadratic, it's easier to factor. So now I can factor everything here to find all zeros. And open two parentheses, x, 30, which is 5 times 6. I can use 5 and 6 to get -1. So I'm going to say minus 6 plus 5. Because negative 6x, 5x to check that. And when you add, it's going to be negative x. So now how many zeros do we have? The actual zeros, not the possibles. We have x plus 1 equals 0. That means x equals -1. The second zero, x minus 6 equals 0. That means x equals 6. And the last zero, x plus 5 equals 0. That means x equals -5. So how many possible zeros we have? We have 2, 4, 6, 8, 10, 12 possible zeros. But the actual zeros, how many? 1, 2, 3. If you look to the actual zeros, it exists here. -1 and 6, the positive 6, and -5. So these are the actual zeros. How we find that? By using the possible zeros. I start with the first one, k equal 1. The remainder is not 0. So I'm going to cancel the whole thing. I'm going to go to the -1. If the remainder is 0, that means this is the actual 0. If it's not, you're going to cancel it and you're going to move to the +2 and keep going to -2, keep going to the +5, -5. Okay? Let's go a little bit up. So let's check these. That means the actual zeros is going to be -1, comma, 6, comma, -5. I think you don't have to write down in orders. That's it for this example. Let me know. Because also one of the possible zeros is ±3 and ±10. You're right. We have to add these. But it's not going to be actual zeros from the polynomial. That's good. Let's go to example 14. We're going to do exactly the same technique. I'm telling you, I don't know the solution, so we have to work on it. 14 is f of x equal x cubed minus 73x plus 72. So we're going to do exactly the same technique. So first of all, there's a missing term here. So when you use the scientific division, don't forget the x squared. That means a not equal 72 and a and equal 1. So P is going to be all possible zeros for 72, which is 1, I think 72, 318 also, to 324. So it's a plus or minus 1, and let's say plus or minus 72. There's many numbers with this one. And with 2, 72 divided by 2 is going to be 36. That's mean plus or minus 2 and plus or minus 36. Let's keep going. 3, you can't. 4, so 72 with the 4 is going to be 18. That's mean plus or minus 4 and plus or minus 18. Let's keep going. 72, we count with the 5. Let's check with the 6, 12. So plus or minus 6. And here, plus or minus 12. Check, do we have another number? 72 with 8, it's going to be 9. I think this is the last one. So 8 and 9. Plus or minus 9 and plus or minus 8.
You can do 3 and 24, I think.
Oh yeah, I said that and I forgot it. 5, 3, 24, yes. So plus or minus 3 and plus or minus 24. With the 9, yes, we got it. That's why with the 6, that means it's gonna work with the 3. With the Q, it's only plus or minus 1, so it's not gonna change anything. That means all possible zeros is going to be all these numbers. Let's write down plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 9, 12, plus or minus 18, because I'm dividing these numbers by 1. It's not going to change anything. Plus or minus after 18 is 24, plus or minus 36, and plus or minus 72. So all these, the possible zeros. We're not going to use these possible zeros like all these possible zeros. We're going to start from the first one. I'm going to say k equal 1. So let's start when k equal 1, the first possible zero. And let's check if it's work or no. K equal 1. Here is the polynomial. I'm not going to forget. It's x cubed plus 0x squared minus 73x plus 72. If you forgot, this 0 is going to be wrong. Because here, 1, 0, negative 73, and 72 here. How I'm going to find this is the right 0, the remainder is supposed to be 0. So this is 1. 1 times 1 is going to be 1. 0 plus 1 is going to be 1. 1 times 1 is going to be 1. Negative 73 plus 1 is going to be negative 72. 1 times negative 72 is going to be negative 72. Add these together is going to be 0. R of x equals 0, so that means this is the right 0. So to write down the factor for this one, it's x minus k. That means equal x minus k is 1, so minus 1. So this is the right 0. I already know this is the constant. This is x. This is x squared. That means f to the x equal. Write down x minus 1. And here is x squared plus x minus 72. Now, this is a quadratic. We can use factor this one. It's easier for us. X minus 1. I'm going to open 2 parentheses. Here is x and here is x. 72, I can use 9 and 8. So I'm going to say 9 and 8. I need to get positive, so I'm going to put plus and minus. Let's check that. This is the right option. This is 9x, and this is negative 8x. Add these together is going to be 1x. So this is the right option. That means I have 3 zeros. Check how many possible zeros, but the actual zeros is just 3. So x minus 1 equals 0. That means x equals 1. And x plus 9 equals 0. So x is going to be equal -9, and x minus 8 equals 0. That means x is going to be equal 8. So we have 3 actual zeros for this polynomial function, which is 1, comma, -9, comma, and 8. Let's work on this one. Find the zeros. That's the only thing they're gonna ask you. So we need to find A naught is 3 and AN is 1. That means P is going to be equal plus or minus 1 and plus or minus 3. That's the only factors for P. Q, the factors for AN, which is plus or minus 1. So let's find P over Q here. P over Q is going to be 1 divided by 1, so plus or minus 1, and 3 divided by 1, so plus or minus 3. So we have only 4 options. Let's check with the first one when k equal 1. So when k equal 1, don't forget the missing term, because this is t cubed minus 3 t squared plus 0t plus 3. If you're missing the 0, everything is going to be wrong. So here is 1. So here is 1, -3, and 0, and 3. Write down the first one. 1 times 1, 1. Add these together is going to be -2. 1 times -2 is going to be -2. Add these together is going to be -2. 1 times -2 is going to be -2. Add these together is going to be 1. R of x not equal to the 0. That means I'm going to cancel this one. I can't choose k equal 1. I'm going to go to the -1. I'm going to say k equal -1. Do the same thing. -1, and here's 1, -3, 0, 3. Write down this number. -1 times 1 is going to be -1. Combine these together is going to be -4. -1 times -4 is going to be 4. Add these together is going to be 4. Now -1 times 4 is going to be -4. Add these together is going to be -1. That means in this case, also R of x not equal 0. So it means this one also is not a real zeros. Let's keep going to the next one. Now k equal 3. So I'm going to say here is a 3, 1, -3, 0, 3. So here is the 1. 3 times 1 is going to be 3. Add these together is going to be 0. 3 times 0 is going to be 0. Add these together is going to be 0. 3 times 0 is going to be 0. Add these together is going to be 3. Also, R of x, the remainder, is not equal to the 0. Let's go to the last option when k equal -3. So we're going to cancel this one too. When k equal -3, let's check. 1, -3, 0, and 3. So here is 1. -3 times 1, -3. Add these together, -6. -3 times -6 is going to be 18. Add these together, 18. -3 times 18 is going to be -72, I think. Is that 72? 3 times 18, 54. 54, yeah. Negative 3 times is going to be 54. Add these together is going to be 57. And also the remainder is not equal to the 0. In this case, all possible zeros, when I use it, I didn't get remainder equals 0. In this case, we can't factor this one. So we're just gonna type here. They're telling you enter D and E does not exist. D and E. So how many zeros? We have 4 possible zeros, and none of these it's worked. So the only method you can use this one, you can't factor it because it does not exist. And you can't use a quadratic formula because it's a cubed. So just type D does not exist. If you look to example 16, the polynomial function, there is no missing term, cubed, squared, and 1, 0. Let's say A naught equals 16 and AN equal 4. Now, next step, P is going to be equal the factors of 16, which is plus or minus 1, plus or minus 2, plus or minus 4 times 4, and the plus minus 8, because 2 times 8 is 16, and plus or minus 16, because 1 times 16 is 16. So all these are possible zeros. For P, for the factors for P, the Q is the factors of N, which is plus or minus 1, and the plus or minus 2, because 2 times 2, 4, and the plus or minus 4, because 1 times 4 is going to be 4. Now, the possible zeros is going to be P over Q, which is 1 divided by 1. Check how many possible zeros we're going to get. 1 divided by 1 is going to be 1. 2 divided by 1 is going to be 2. 4 divided by 1 is going to be 4. 8 divided by 1 is going to be 8. 16 divided by 1 is going to be plus or minus 16. We have to keep going because now we're going to start dividing all P by 2. So focus here. 1 divided by 2, so plus or minus 1 over 2. 2 divided by 2 is going to be 1. That means it's going to be plus or minus 1, which is the same thing here. So I don't have to write down this again. 2 divided by 2 is going to be 1, which is exist here.
So
Plus
if
or-
you don't have to write it down again, it's still counted?
Yes.
Okay.
Yes. If you want to write it down again, it's fine, but cancel the similar thing, okay? Because when I say 2 divided by 2 is going to be plus or minus 1, which is the same thing here, okay? So on the test, the actual test is going to be right. But when you plug in your answer on whoopee sign, here is going to be wrong, okay? If they ask you about the possible zeros, because you repeat the same number.
Okay.
So next number is 4 divided by 2 is going to be 2, which exists here. So I don't have to write down this again. 8 divided by 2 is going to be 4. I don't have to write down this either. 16 divided by 2 by 4 is going to be 16 divided by 4 is going to be 4, which is already exists here. So I'm done from the second number. The third one, I'm going to divide everything here by 4. 1 divided by 4, so it's going to be plus or minus 1 over 4. 2 divided by 4, how much? 2 divided by 4. 2 divided by 4. Can you simplify it to half? Is that the same thing here? So it exists
Yes.
here.
Mhm.
So you have to be careful, I'm telling you. 2 divided by 4 is going to be half, which is exist here. 4 divided by 4 is going to be 1, exist here. Now 8 divided by 4 is going to be 2, exist here. 16 divided by 4 is going to be 4, which exists here. So that's it. You see, so you don't have to repeat the numbers. I'm telling you, if you're doing the test on paper, yes, I'm gonna accept that because it's gonna be the same number. But on WebAssign, they're not. And with math, you don't have to repeat the numbers. So you don't have to repeat 2 twice, 4 twice. No, just write down the difference. Okay. So here is the possible zeros. Always we're gonna start with the first one. So I'm gonna say if k equal 1, k equal 1, I'm gonna write down the coefficient here, which is 4, negative 33, 72, and negative 16. Now, here is the first number. 1 times 4 is going to be 4. 1 times 4 is going to be 4. Now, minus these, because negative 33 plus 4 is going to be negative 29. 1 times the 29 1 times 29, negative 29. Add these together is going to be 4, 3, 7, yeah. Let's check 72 minus 29. Yeah, 43. And 1 times 43 is 43. Minus these together is going to be 27. So positive 27. And if you check here, the remainder is not 0. That means this is the wrong possible 0. Let's check the negative. Negative 1. And you have to check negative positive 2 and negative 2. So k equal negative 1 also is not going to work. I need you to check that. And the same thing, k equal 2 and k equal negative 2 also is not going to work. You have to check that. So you're going to do exactly the same steps. When you reach k equal 4, that's what's going to work. So the main thing, what I'm telling you that you're going to check k equal 1. It's not going to work. You're going to go to the negative 1. And you're going to do the same steps here. You're going to get the remainder not equal to 0. You're going to go to k equal 2. And then you're going to go to k equal negative 2 and keep going. Let's check if k equal 4. I'm not sure if it's work or no. I'm just guessing, which is wrong. We don't have to guess. So let's say 4. 4, negative 33, and 72, negative 16. So write down this. 4 times 4 is going to be 16. And now 33 and 16 is going to be 17. Negative 17. If you multiply these together, so times negative 4 is going to be 8, which is negative 68. Now 72 minus 68 is going to be 4. It's going to be 4, yes. Now 4 times 4 is going to be 16. Add these together is going to be 0. So this is the remainder equals 0. R of x equals 0. In this case, this is the right k. So here is going to be x minus k. That's mean equal x minus 4. So the polynomial function f of x is going to be this one is going to be x minus 4, and this is the constant x and x squared. So it's going to be x squared, 4x squared minus 17x plus 4. Now f of x is going to be equal x minus 4. I can factor this one. Let's open two parentheses and check how we're going to write it down. If you say 4 and 4 here, 16, and you get 17 and 1. So let's say 4x here and 4 here. And with the 16 and 1, here's x. And I'm going to add down 1 here. Now, this is 16 and this is 1. So I'm going to put negative and negative. That's mean negative 1x, negative 16x. When you add it together, it's going to be negative 17x. So this is the right one. That's mean we have 3 factors for this polynomial, which is the first one is going to be 3 zeros or 3 factors with the parentheses. So x minus 4 equals 0. That means x equals 4. And 4x minus 1 equals 0. That means x is equal 1 over 4. And the last one, x minus 4 equals 0. That means x is going to be equal 4. That's it for this example. That because we have x equal 4 and x equal 4. When you type your solution, you don't have to write down this twice because it's the same thing. So you're just gonna type. So the first thing, there is no missing term here, which is good. So a not equal 25 and an equal 1. That's mean p is going to be equal plus or minus 1 and the plus or minus 5 because 5 times 5 and the plus or minus 25. With the q is just the plus or minus 1. So the possible zeros, p divided by q is going to be, just divide these numbers by 1, which is going to be plus or minus 1, plus or minus 5, and the plus or minus 25. So that's it. This is the zeros for this example. Let's start with 1. When k equal 1. I hope it's worked when k equal 1. 1. So here is 1, 1, 25, and 25. 1, negative 25, and negative 25. So here is 1. 1 times 1 is going to be 1. Add these together is going to be 2. 1 times 2 is going to be 2. Add these together is going to be negative. That's not going to work. Negative 23. Now, 1 times negative 23 is going to be negative 23. Add these together is going to be 8 for negative 48. So the remainder is not 0. That means this is not. The same thing when k equal negative 1. K equal negative 1. Let's check that. Negative 1. So here's 1, 1, negative 25, and negative 25. So here is 1. It's going to be negative 1. Add these together is going to be 0. Negative 1 times 0 is going to be 0. Add these together. Wow, it's going to work. So negative 25. You see, I didn't know it's work or no. Add down the 1. -1 times 1, -1. Add these together is going to be 0. Now, -1 times 0 is going to be 0. Add these together is going to be -25. -1 times -25 is going to be +25. Add these together is going to be 0. So r of x, in fact, equals 0. That means this one is going to be x minus k, which is equal x minus -1, which is equal x plus 1. So here is the first number. This is the constant. This is x, that means 0x. And this is x squared. So be careful here too. That means 0x. So our polynomial is going to be f of x equal x plus 1 and x squared minus 25, because x is 0. Now this is super easy to factor it. It's going to be x plus 1, and this is difference between two squares. So x minus 5 and x plus 5. That means we have 3 zeros. X minus 5 equals 0. So x is going to be equal 5. And x plus 1 equals 0. That means x equal -1. And x plus 5 equals 0. That means x equal -5. So 3 zeros. The possible zeros here, we have to write down the positive and negative. So 1, comma, -1, comma, 5, comma, -5, comma, 25, comma, -25. This is the possible zeros. Now we already know we have 5, -1, and -5. Which one is going to be the graph? -5 and 1 and 5. This is the right one, because the difference between this one, -5 and -1. Oh, we have -1. So this is the right one, not 1. -5 and -1 and 5. If you look here, it's -1 and just 6 here. So this is wrong. If you look here, this is -6, not -5, and this is 1. So the only graph, this one is going to be the right one. Now, they're telling you which one is the actual real zeros. It's going to be 5, -1, and -5. Let's check that. That's it for this one.